at 9-3, which really is just like kind of 9-1 and 2. Ask a couple other questions that maybe are kind of good to go through, but first it says determine the standard error of the mean, so we kind of got to go back, right? And really that's just this part of the formula, right, that we're using is x plus or minus z times the standard error of the mean. Standard error of the mean is our standard deviation divided by the square root of our n, okay, or sample size, right? And so we would have to do this. And I don't know that you guys are asked to do this on any of these, but it's good practice anyhow. So again, here I just have the standard deviation, which is given to us, divided by the square root of 250 in this case. So I need this 250 to the 1/2. That should be right. So there I have it. Okay, and then this one is like yours for number 2, so it might help you out a little bit there, but because it's the 95% confidence level, right? And so we got to go look up what that is, which would be 0.475. Is that right? I believe half of 95. So I just come here, I'm looking for 0.47. Oh, look at that, it's a perfect one. 1.96. 1.96. You probably get used to that. We end up using that number a lot. So, because the 95% confidence level is a fairly common level. So, 1.96, boom. So 1.96 times our standard error of the mean. And we have basically our number that we plus or minus from x. We have this solution which we plus or minus from x, which is our mean. I'm sorry, our sample mean right there, 20. So equal to this plus that and subtract it, and so we're 95% sure that our mean of the population would be between those two numbers. You guys, for 4, it says suppose you know and you know the standard deviation and you want an 85% confidence level, what value would you use as z in formula 9.1 or in this formula basically? So basically you're looking at the 85% confidence level, or what's that, 0.425 in that case.